Okay, so this is the screencast for worksheet 5 on electrolysis. So here are the answers for the MCQ questions. Okay, so for the first question, which of the following has the higher conductivity? So when we talk about conductivity, right, we need to look at two factors. We need to look at the number of free ions or electrons. We also need to look at the charge. So let's say I have the same number of moles of ions, let's say Ne plus and Mg2 plus, then if they have the same number of moles, then since the charge of Mg2 plus is higher, then the conductivity for Mg2 plus is higher. Okay, so let's look at the options here. We have gaseous hydrogen chloride. Now we know that hydrogen chloride in the gaseous form is a covalent compound, okay, covalent molecule. So therefore, there's no free ions to conduct electricity. Ethanol is also a covalent compound. So that's out 2, A and B out. C is solid sodium chloride. Since an ionic compound in the solid state cannot conduct electricity, it is also out. Therefore, we are only left with the last answer, aqueous lithium fluoride. Question 2. Using the apparatus shown on the right, an electric current is passed through aqueous concentrated copper 2 chloride. Which one of the following occurs at electrode X? Okay, so first, in this diagram, we must identify where is the positive and negative terminal. Okay, the long end is always the positive, the short end is always negative. So towards the positive terminal, what type of ions will move towards it? Okay, towards the positive terminal, we'll have anions. So what anions are present in aqueous copper 2 chloride? We have Cl minus as well as your hydroxide ions. Okay, then for the negative terminal, we have your cations moving towards it. So what cations are present? We have Cu2 plus as well as H plus ions. Okay, which of the following occurs at electrode X? So since they say it is a concentrated copper 2 chloride solution, if you look at the anions, looking at their electrochemical series, we see that chloride is above hydroxide. So by right, hydroxide should be preferentially oxidized. However, since it's a concentrated chloride solution, due to the concentration effect, your chloride will be the one that is preferentially oxidized or discharged. So what will happen at this electrode? We will see that chlorides will lose electron to become chlorine gas. Okay, so this is the oxidation reaction. If we look at the options, we see that B is the one that's correct. Okay, the table below shows, for question 3, the table below shows some result of electrolysis experiment. Okay, we have concentrated sodium chloride and aqueous copper 2 sulfate. Which one of the following will complete the table? So, anode and cathode both are inert electrodes. Okay, so what is the product at our anode? Anode being the site of oxidation. So, what is the substance that can be oxidized? It will be your anions. So, we need to think, is it hydroxide or is it chloride that is oxidized at the anode? Again, note that the term is concentrated. So, once again, chloride is the one that is oxidized. But they ask you for the product, and the product is not Cl minus. The product will be chlorine gas. Okay, let's look at the second one. Aqueous copper 2 sulfate with copper anodes and cathode. Okay, the anode dissolves into the solution, which means that your Cu2 plus has been Cu has been oxidized to Cu2 plus. So what's your product at the cathode? Okay, your product at the cathode, we must think of what are the cations present. We have Cu2 plus as well as your H plus. So if you look at your electrochemical series, we see that Cu2 plus is below H plus. So Cu2 plus will be preferentially reduced and copper will be formed. So if we look at our options, first option X should be chlorine, second one should be copper. The only answer is A. Question 4, almost everyone got it correct, so I won't go through. Question 5, a constant current was passed through aqueous copper 2 sulfate using copper electrodes. Okay, so aqueous copper 2 sulfate, copper electrode, constant current. At regular intervals, the copper cathode, the negative electrode, was removed and weighed. Which one of the following graphs represent the mass of copper cathode plotted against time? Now, I've drawn this diagram here to help you understand. We are talking about the negative electrode. So what type of ions will move towards the negative electrode? Again, it will be your Cu2 plus as well as your H plus. We have already determined that Cu2 plus should be below H plus in your electrochemical series here. So Cu2 plus will be preferentially oxidized to Cu. So that's why there's a gain in mass. So if you look at the graph, okay, first of all, your C is out because the mass should not decrease. Okay, let's look at the other ones. We notice that the mass of copper cathode started at 0. Also, obviously that's wrong because we started out with some mass of copper. Okay, it just got heavier and heavier. So the answer is A. Now, why is the gradient a straight line instead of a curve? So you must think of a constant current. Because the current is constant, it means that the flow of electron is also always constant. Okay, for every Cu2 plus that becomes copper on the negative electrode, there is one copper that is replenished into the electrolyte. So this ensures that the concentration of Cu2 plus in the solution is constant. Okay, if the concentration is constant, it means that the rate of reaction should also be constant. That's why for question 5, answer is A. Okay, question 6, in a series of experiments, the following quantities of ions were discharged in electrolysis, which requires the largest quantity of electricity. Okay, largest quantity of electricity, what kind of quantity do we measure electricity by? Okay, it's actually, you can actually look at it as the number of moles of electrons. Okay, so write out the half equation for all these reactions, and then we can calculate the number of moles of electrons used. Okay, let me write out the half equations. Okay, so after you write out the half equation, now let's look at the options one by one. A says that 1 mole of Cu2 plus ions. So with 1 mole of Cu2 plus ions, we have 2 moles of electrons used. Okay, for option C, okay, 3 mole of bromide ions. Here the ratio is 2:2. So if I have 3 moles of bromide ions, I should have 3 mole of electron as well. Here, I have 2 moles of aluminium ions. If you look at the ratio here in the half equation, it is 1:3. So having 2 moles of Al3 plus ions means I need 6 moles of electrons. Okay, 4 moles of hydroxide ions, I have 4:4 here, so it means I have 4 moles of electrons used. If we compare everything, you will see that answer is B because it requires 6 moles of electrons. Question 7. An article to be gold-plated is made the cathode of a cell. What will be suitable materials for the anode and the electrolyte? Now, we have done questions about electroplating before. Okay, here they say that the item to be plated, let's just draw a circle. 1, 2, plate. It should be at the negative terminal. Why is that so? It's because your metal cation can be reduced to the metal on the negative terminal. Okay, since you want to plate it with gold, this metal must of course be gold. Okay, in this case gold 2+. So what should be the other side at the cathode? At the anode, I mean. Okay, again, like the previous example of using copper, we want to have gold as the other electrolyte so that it can ensure that the concentration of gold ions in the solution is not used up. Okay, so that you can just keep on plating it. So the answer will be gold as well as equals gold 2 chloride. Okay, question 8. Aqueous copper 2 sulfate was electrolyte using different electrodes as shown in the diagram. In which experiment did the concentration of aqueous copper 2 sulfate remain constant? So again, when we want the concentration to remain constant, what goes in must come out. Okay, and if you look at the option, here we have carbon and platinum, inert electrons, inert electrodes. Okay, here inert electrode, here also inert electrode. Now, notice carefully where the copper electrode is placed. Okay, here, this is positive, this is negative. Okay, so what it means is your Cu2+ ions should move to this side and become copper at this end. Okay, what will happen at the carbon electrode? Okay, since it's not a reactive electrode, we only need to look at the anions present. So therefore, what's the anion? Oh, okay, copper 2 sulfate. So it's either sulfate or hydroxide. It's definitely not sulfate, so answer is hydroxide. So we can see that the product will be water as well as oxygen gas. So you can see that your Cu2+ ions are not being replenished. Okay, it's just constantly being used out to form more copper on the copper electrode. Same thing goes for here. Okay, because it's also an inert electrode, so your Cu2+ will just keep forming copper here until all the Cu2+ is being used up. Okay, over here is the same. Your Cu2+ will also move here to become copper. Okay, so it will again continue until all the copper 2+ ions are being used out. So the correct answer should be C, because here we have copper as the reactive anode. So only the anode will experience oxidation and release Cu2+ ions into the solution, whereas Cu2+ ions are also being used up at the same time. So this ensures that the concentration of Cu2+ remain constant. Question 9. A solid deposit of element X is formed at the cathode when an aqueous solution containing ions of X is electrolyzed. Okay, which statement about element X must be correct? Let's look at this. Okay, at the cathode, this is the side of reduction. Reduction means what? Means I gain electron. Okay, so the aqueous solution containing ions of X, it means that the ions of X gain electron to form your X. What does it tell you about X? X should be a positive cation gaining electrons to form X. Okay, so the answer should be that they gain electrons at the cathode. Question 10, well, a lot of you got this wrong, so let's look at this carefully. Which one of the following sets of changes occurs during the electrolysis of dilute sulfuric acid using platinum electrodes? Okay, let's draw it out. Platinum electrodes are inert. So this is the positive, this is the negative. I have H2SO4. Now what can be attracted to the negative electrode? It must be my cations. Okay, cations include H plus only. Anions to the positive terminal, SO4 2 minus, OH minus. But SO4 2 minus cannot be possible, so OH minus will be discharged. Okay, so what will be formed at the anode? Anode is here. This is the cathode. Okay, so at your anode, we will see that it gives you, let me use another color. Gives you oxygen gas here and hydrogen gas here. Okay, so you look for oxygen at the start, hydrogen at the cathode. So we are left with C and D. Okay, so now it's a question of whether the concentration of sulfuric acid will increase or decrease. Okay, now if you look at this carefully, let's write out the overall equation. The overall equation should be 2H2O gives us H2 plus O2 gas. So you can see that actually we are using up your water. So when you use up water, it means that the concentration of the solution should decrease. The concentration of the solution should increase because water is being used up. Okay, let's look at question 11. The following three different solutions were electrolyzed using inert electrodes. Which of the following solutions produce hydrogen at the cathode? Okay, let's look at examples one by one. So, concentrated sodium chloride. Since it's concentrated, chloride will be produced at the anode. Okay, remember it's oxidation. So, chloride lose electron to become chlorine. So, at the cathode, since it can never be sodium, it must be hydrogen gas. Okay, concentrated sulfuric acid. Now, sulfuric acid only has H plus as the cation, so definitely at the cathode, we have hydrogen gas as well. Third, dilute sulfuric acid. Now, whether it's dilute or concentrated, again, H plus will still be the one that's coming out. So, again, at the cathode, we'll have H2 gas. So, answer will be 1, 2, 3. Question 12. During the electrolysis of an aqueous solution of cerium, 70 grams of cerium is deposited at the cathode by 2 moles of electrons. Which of the following is the most likely formula of cerium ions? Okay, so this you need to do some calculation. 70 grams. So we have cerium. The number of moles of cerium is 70 over 140. Okay, mass over MR will give you 0.5. Now, 0.5 mole of cerium needs 2 moles of electrons. So, what it means is that I need to gain 4 moles of electron for every 1 mole of cerium formed. So, it tells me that this must be Ce4+. Question 13. The circuit shown was set up. At first, the ammeter showed that a current was flowing. Some dilute sulfuric acid was added to liquid Z, and the ammeter showed that the current was greatly reduced. What could liquid Z be? Now, when will current, the ammeter showed that the current was greatly reduced. So again, we talk about current being the movement of charged particles. Charged particles. So when current is greatly reduced, it means that your charged particle has decreased. Okay, there's lesser charged particles moving around. So why is that so? When you add HSO4 and then it reduces the current. Now let's look at your answers one by one. We have barium nitrate with sulfuric acid. Okay, we know that this will precipitate out. Okay, so, oh no. Okay, so you must think, at first I have 2 moles, I have 3 moles of ions. Okay, after precipitating out, I ignore these two, I have 4 moles of ions. So actually, overall, your conductivity should increase. Right? The current should increase. Let's look at B, sodium hydroxide. If you look at sodium hydroxide again, at first, I had Na plus OH minus, then I add H plus SO4 2 minus. Okay, we know that this will form water. So initially I had 2 moles of ions. After precipitating out, I have 3 more of ions. So that's why here it should increase as well. Now, the answer is actually C. Why is that so? If we look at the start, having Ca2 plus, OH minus, OH minus. Okay, I have 3 moles of ions. At first, I have 3, then I add H2SO4. H plus SO4 2 minus. Now you notice that they will all combine. Okay, this will neutralize, and CaSO4 is insoluble solid. So you will either become water or it will become a precipitate. So that's why in the end there's actually no ions left. From 3 to 0 ions, that's why conductivity decrease. Now, if you add dilute sulfuric acid to water, you are actually increasing the conductivity, since water by itself is not a very good conductor. So you are adding ions to something that's not a very good conductor, it will increase the conductivity. So answer is C. Okay, question 14. Which particles are responsible for the conduction of electricity through number 1, metals, number 2, electrolyte? This is actually chemical bonding. So for metals, remember that we have the delocalized electron. For electrolytes, we are talking about ionic solutions or liquid state. So it is their ions. Do we need to care is it the positive or negative ions? No, right? Both ions can conduct so long as you are charged. So the answer will be D. Question 15. The diagram on the right shows the electrolysis of. Now, this diagram should be familiar to you. This is actually your. Oh, I forgot what's this called. Okay, it's a bit late at night. Okay, I forgot what's this diagram called, but it's in your notes. So you can see that I use this to teach you about the electrolysis of water. Okay, why is there a difference in the amount of gas produced? It is because if you write out the overall equation, we know that for every mole of oxygen gas, there's 2 moles of hydrogen gas produced. Okay, the overall equation is, okay, right? So similarly, here you should be looking for something that will give you the exact same products. Okay, if you have copper 2 sulfate solution, copper 2 being lower than H plus in the electrochemical series will become Cu instead. Okay, the other side I'll have O2. So this is wrong because I need a gas to be evolved. Okay, second question, concentrated sodium chloride will have H2 gas coming out and Cl2 coming out. If we write the overall equation, you should see that it is okay, and you see that they have the same ratio. So it is not what we see in this diagram here, therefore B is also wrong. Concentrated hydrochloric acid, again, I'll have H plus and Cl minus as the species being discharged. So again, I have a 1:1 ratio, which is not what is shown in the diagram. So C is wrong as well. So if you look at dilute sulfuric acid, the cations that are present is H plus, and ions are SO4 2 minus as well as hydroxide. We know that SO4 2 minus will not be discharged, so H plus will become your H2, OH minus will become your O2, which gives us this overall equation and give us this diagram. Question 16, the diagram shows the electrolysis of potassium iodide solution and molten potassium iodide. What are the substances formed at cathode of cell 1 and cell 2? Okay, let's see. They are asking for cathode, which is the site of reduction. So what can be reduced is your cations. Okay, so if we look at the molten potassium iodide, there is only one cation here, which is your K+. So K+ will gain an electron to become become potassium. So over at the potassium iodide solution, we have a choice of two cations. We have either K+ or H+ since it's a solution. Now K+ is way above H+ in the electrochemical series. See, K+ is way above H+. So we know that H+ will be the one that is discharged to form, let me just write this properly. Okay, it will form H2 gas. So what are the products? Cell 1 will be your hydrogen, cell 2 will be your potassium. Okay, question 17. Again, a lot of people got this wrong. In an electrolysis experiment, the same quantity of electricity. Now, when they talk about quantity of electricity, we again think about the number of moles of electrons. Deposited 32 grams of copper and 12 grams of titanium. So first, we need to calculate the number of moles of copper here. Okay, copper, the mass number is 64, so 32 divided by 64 gives us 0.5. Okay, next, we know that writing the half equation, Cu 2 plus 2 electrons gives us Cu. So the ratio of copper is to the electrons is 1:2. Hence, the number of moles of electron should be 1 mole. Right? Okay, so with 1 mole of electrons, I have 12 grams of titanium. Let's look at the number of moles of titanium. 12 divided by, let me find titanium. Where's titanium? Okay, found it. Okay, so it's 48. Divided by 48, I have 0.25, right? Yeah. So the ratio of the electron is to titanium is 1 ratio of electron is to titanium. Okay, look at the number of moles. is 1:0.25, so it is 4:1. Therefore, I know that for titanium to be formed, I need 4 electrons to be added. So it means that titanium had a charge of 4 plus. A. Question 18. The diagram shows the apparatus used to electrolyze that 2 bromine using inert electrode. Why does the bulb only light up when it is melted? Very simple. Why must we have molten ionic compounds or aqueous ionic compounds? Because solid ionic compounds do not conduct electricity. Okay, answer is C. Yeah. Question 19. A sample of copper contains as impurity a metal below it in the reactivity series. Okay, this English is a bit strange. What it's saying is that this copper has an impurity, and that impurity is a metal that's below it in the reactivity series, meaning that this metal should be preferentially reduced over Cu, but Cu is preferentially oxidized over this metal. Okay, remember lower is easier to reduce, but higher is easier to oxidize. So over here, the loss in mass of the anode was 50 gram, and the gain in mass of the cathode was 45 gram. What was the percentage purity of this sample of copper? Oh, you don't even need to understand anything. Okay, so now what we need to know is the impure part, there's a decrease in mass of 50 gram. But over here, okay, where there's a new metal form, there's a gain in 45 gram. So what's plated over here, right, are your pure copper. Okay, what is lost over here is your pure copper as well as your impurities. So your pure copper would be 45 over 50. Okay, this is percentage purity. Pure over impure times 100%, 90%. Okay. Last question. An ammeter can be used to detect electron flow in a circuit. Which circuit will produce the highest reading in the ammeter? Okay, let's look at this. Oh, so this is a simple cell. Oh, finally one question on simple cell. Okay, remember we talked about simple cells can test the difference in the reactivity series. So the further apart on electrochem series, you can see that there's a increase in voltage. Okay, there's a increase in voltage. So if you look at these, we have copper, magnesium, copper, zinc, copper, iron, copper, zinc. Okay, let's highlight the options: copper, magnesium. Second option, copper, zinc. Third option, copper, iron. So you can see that with magnesium, there's a biggest difference. So we choose A. Yeah, and if you compare the electrolyte, right, you can see that since this one they have ions, H plus and SO4 2 minus, these two are better conductors than your sugar solution and your distilled water. Okay, so that's all. Answer will be A. If you have any question, please comment in the Google Classroom post and I'll try to answer it. Thank you.